I will talk about maps, then the new data type, and what the present situation is, and what the plans are for the future with this maps. So this is the agenda for my speech. Short about the background about maps. Then we have what we have in OTP 17.0 and the current implementation there and the limitations. And then we call it experimental. I will explain why. And then the plans for 18 in first quarter next year or so. So we introduce maps because we want to provide an efficient and easy to use alternative to records, dicts, GB trees, ETS tables, prop lists. Of course, it's not always good to replace this with maps, but in many cases it could be. We want to introduce and complement the record data types with something that can supersede them where suitable. And we want to get rid of the include file dependencies which you get into when you use records over module boundaries. We have an approach for maps from two directions. You have one map which is here. When you can have any term as a key, you can have many keys, hundreds, thousands, typically a few instances with identical keys. You can compare that what you have with dict and GB trees, and prop list is maybe somewhere in between. The other approach is direction here is like what we use records for today. Few instances, many instances, and possibly many instances with exactly the same set of keys. You usually have atoms as keys. The number of keys is usually small. And we try to combine this into the same syntax, but we have a different representation for these two. So now we have introduced maps in OTP 17. And by doing that, introducing a new data type in Erlang, it's quite some work, more than you expect. Of course, you have the Erlang VM and the compiler. They are impacted of this. The Erlang shell, the debugger, dialyzer. Then we have the distribution protocol. And we have the BIFs converting to the external representation to and from. And we have the C library for acting in the distribution protocol. The Java library for the same. They must know about maps. We have more. We have ETS and tracing, where we have match specifications, which must know about maps. NIFs, you need an API to manipulate maps. You must be able to do hashing and comparison with maps. Maps must fit into the term ordering in Erlang. And we also have other applications which handle internal types and syntax, like Hype, the native code generation, edoc, syntax tools, and aldocian for building the documentation. And I suppose there are even more things, but this is something to mention. So now, the current implementation in OTP R, not R, only 17.0. We have maps supporting only literal keys. It is the small maps implementation with keys less than 64. I mean, it supports more, but it's a linear search for the key, so it's when it goes up to hundreds and so on, it will have bad performance. And when you have literals, it's not so easy to create big maps anyway. You can say that this is the record part of maps. So, what we support today, syntax, creation. This is the syntax done for creation. Hash, curly brackets, and inside you have the key, you have this operator, and the value. And with this operator you introduce a new key. And then we have some, you can also create a map with many keys at the same time. And you can have you can have any term as a key. Here is a tuple as a key. You can update. Here you are updating a new or existing key with a value. You already have a map in the variable m here. In the next case here, you use another operator, and that is updating an existing key. So you will get an exception here if the key doesn't exist. And note that in the current implementation you have to have literals here. You cannot have variables here in the syntax. So this is also an example of updating an existing key. And the reason for this is that when you're using them like records, you don't want to introduce new keys by mistake. So if you use this operator then on purpose, you have to choose an existing key. You can do pattern matching. Here you match for any map and bind it to variable s. Then you use s and update the state key with a start value. Here you match a map with the key state, which must have the value start. This map can have any other keys as well then. Another example of pattern matching is here. Suppose that this file read file info, it already exists today, but it returns a record today. Suppose we change what it returns to a map, which would be convenient because you would then not need the include file anymore for the record definition. Now you can match then the type of file and the modification time, for example, like this. Then we will of course not change this function in an incompatible way, but we have to invent a new function then. So, in summary then, we have the syntax, and some of them corresponds to functions we also have in the maps module. So we have this, create a new map, an empty map. This one puts a new value for a key, and this one updates an existing key with a new value. You have functions update, put, and this is not exactly. The matching here is you can match out a key and value, and you can do the same with a find function, but it returns OK, tuple OK, comma result here, or error. Then we have the single value get, which is not implemented yet because we are not really sure how it should look like, or if we should have it at all. And we have the guard functions, isMap and map size. And these you can of course use them without the Erlang module in front. They are so-called auto-imported functions. So then we have more functions in the maps module. And I can tell you more about them here. We have the guard bifs. Test if it is a map, any kind of map. It's the first one, isMap, in the same manner as other data types. Then we have the map size. It's the number of key value pairs. Can use it in guard as well. Conversions from to and from a list. I think it's obvious what it does. It converts a list of key value tuples into a map. This one, and this one, it goes the other way, from a map to a key value tuple list. And observe this sorted order. It's the term order of the keys. You have more functions here. You can create the map. You can test if a certain key exists in a map. You can get a key. And you can put a key. If I go back here, of course, today we only support literals in the syntax for keys, but by using this from list, you can create a very big map with variables as keys if you want to. But it will not get good characteristics if it's bigger than, say, 100, 200 keys or so. Some more functions here. Find. You can delete keys. You cannot do that with the syntax. You can delete one key with remove, and you can delete many keys without. Then you can get a list of all the keys in sorted order, or you can get a list of all the values in arbitrary order. I don't know why we say like this. I think it's because we don't want to promise anything. I assume it will be the same order as for the keys here by default, but we don't want to promise it. And you can fold over a map with a function, creating a new map. And then you have a map over map. And you can merge two maps. And this is, for example, useful if you want to create maps with default values for some keys. The internal representation is like this. You have come in here from the pointer from the heap, and you get the header, and you have the size of the whole map. Then you have a pointer again to all the keys. They are stored like you store a tuple, and the values comes here. This is then the small the representation for small, and we are discussing now if the break point for changing representation should go with 64 or 32. I think you will choose 64 keys for the break. And this size then, when we implement the big maps as well, we can optimize and hide this size inside the header. It goes together with allocating some new tags which we will use for this. So the keys, they are stored just like a tuple, and they are ordered in the Erlang term order. So then if you update a structure like that, for example, if you already have a map with A equals 1, B equals 2, C equals 3, and then you want to update the existing key B to the atom new as a value, then it goes like this. You make a copy of the value structure, point to the same key description as before. This operator here, where we know that no keys will be changed, no new keys will be introduced. It allows us to do like this. So you can share the key description like this. Oh, that is, I mean, this is the wrong picture. This is the right picture. Big maps, they will be stored in something called HAMT structure, hash array map trees. I think they are invented by Phil Bagwell. It's not exactly sorted out the exact structure and how big it will be, but this is then a combination of hash and tree, you can say. And it's very efficient for updating. That's what I can say now. If you want to know more details about this one, you can discuss it with Björn Egil, who is the implementer of this, and he's in another session right now. The details will be maybe not exactly like this, but similar. And you can read about HAMT on the internet if you want. In the compiler, when you load, when you work with maps in the assembly instructions, you can see an example here that if we have a function which matches on 1, 2, 3, 4 keys in a map, and then changes the values of these 4 keys. You can see the first part of this here, where the match occurs. There is an instruction then, get map elements, which takes this list of keys and makes an efficient match of all of them at the same time. Previously we had separate instructions for each key, and this is then an optimization which we did just before the release of 17. And it goes the same then for the, then we have a put map elements when we have this one. And this is done just because it's very usual that you match more than one key in the same. The external representation, when you send the map over the Erlang distribution, for example, it goes like this. There's a new tag then for map of a 4-byte size field. Size meaning number of key value pairs. And then you get the key value pairs. The key and the value with their respective representation. As you can see here, we have an example, x equals 2, y equals 4. And you get size of 2, you get the tag for atom, we have a 2-byte length field for atom, and then we have the x is 120. And then we have the tag for small integer and the value for small integer, and so here you have the first pair, and then you have the second pair. Okay, what are then the use cases for maps? Here are some examples. For example, you can represent things out from a parser with maps, for example, an XML parser. We don't have it yet, but it might happen sometime. JSON is a very common thing that you could map with maps. ASN.1, similar. Today the mapping is towards records there. You can replace uses of property lists somewhere or in some places. You can use in APIs returning structured data instead of records. Then you get rid of the dependencies to include files. And you can use it in holding the process state. Then you might get an easier upgrade if you want to do runtime upgrade of the process. Here's an example of the JSON mapping. It's quite straightforward. You have here's the JSON structure. Or here is the old Erlang representation in the library mocky.json. And it goes along the same lines for other JSON libraries as well. Here it could be like this, that the JSON key value represents, of course, by a map with key value. And here's a bigger example of JSON structure, and here is the map. Looks almost equivalent to this one, or it is, but looks the same. And here is something about matching out the value ID, which was deeply nested inside here. This is the way you have to do it right now. If we had single value access, it could go like this. Or we can hope to find something even nicer than this. Another use case is, of course, then what I already mentioned, the file read file info, or similar when you return a structured data. You could use a map as a return value. And process info is also that one is actually returning, could call it property list today, with key value pairs in a list. Would be perfect for a map instead. Okay, now about why do we call it experimental in OTP 17? The green here, this is from the documentation. Here is one thing then, why we call it experimental, because it's not completely finished in all aspects. The error returns here will be something else. Today we have bad arg, but this should not be matched by you anyway, I think. It's information. But sometimes it might be reason to match it. The reason then experimental is that, as always, if we introduce something new and then we regret that, oh, we should have done like this instead. It usually goes that many customers jump on the board and they start using it, and then they will not like us to change anything because they don't want to change a single piece of their own code. At least not when they have come out to production. And not even before. So then we have to have this disclaimer for new things to protect ourselves, that we are not 100% sure that we don't want to change something in an incompatible way. But of course we always try to avoid that, and if we need to do it, we will do minimal changes. And we have the plan then to remove this experimental disclaimer in next major release. And what will happen then? Of course, you will be able to have variables as keys, and that's not a big deal to implement actually. But it goes together with having big maps, because it will be easy to create big maps when you have this. And I think, as I said, the breakpoint will go at 64. Not for sure, but around that figure. And we'll call it a hump structure, not the tree structure. This is wrong. And also what we have in the pipe here is extending the matching so that you can match an unbound variable which gets bound in the matched expression. And this is similar what you need for binaries as well. Suppose you have this variable I, which is unbound, but it gets bound here. Then it is bound here. So then you're using the value here for a key lookup in the map. But implementing this goes into how the order of matching is defined in a clause like this as well. And we also have some tentative things that we not at all promise that we have in the next major release. To look more about deep update. And I think that goes maybe together with the single key get. As you saw in the example with the JSON mapping. Could be very useful there. So, this is a summary then. The record part is already there. You can have literal keys, you can have small maps. In OTP 18 you will get variables as keys and you can have big maps. And we will remove the experimental disclaimer. So we want you to use maps so we can get feedback. Because now is the time to change anything, if any time. It's hard to get rid of things that you get into the releases. So that was all my slides. Have any questions?
Does it have a type syntax and stylized one?
Yes, it has. I think I have a picture on it as well. Here, I'm not 100% sure that this is. You can specify a map. I mean, there's limited support in Dialyzer today. It accepts map and you can specify maps, but I don't think it will take care of all information it gets. It will not check. I think maybe you can have types. If all types of the keys are the same, I think you can have that, and all values. But I mean, the details here is not yet implemented, but you can specify them. Dialyzer will accept it. It will not give you all warnings it could do later. Okay. Some more questions?
Yeah, I got one.
Yes.
You had examples on pattern matching, and that was in function clause. But I presume you will have the same in the receive statements as well, the pattern matching. I mean, you can pattern match in a receive statements with a map too.
Yes. Yeah. All places where pattern matching can occur, you can have maps. Already today. With literals.
I have one.
Okay, I just have one question, curious. Why is there no syntax for the get?
What?
Why is there no syntax for get?
Why isn't? Or
Yeah.
why is?
Why isn't there any syntax for get? I mean, you can call maps : get, but I'm just curious. I mean, this doesn't make it mean anything. But
I mean, we have proposed the syntax for get,
yeah,
but we didn't implement it because we were unsure if it was a good idea.
okay.
The particular syntax, or if it is some possibility to combine it with this deep update and things like that.
Okay.
So we are still thinking about that, and we are open for suggestions, of course.
Okay.
Was there a way to match on an empty map?
No, Not in the syntax. No. You have to use the guard bif map size length 0 today. I mean, today the curly brackets only, they match any map.
We are done then. No more questions?
Okay.
Yep.
It might sound a bit stupid, but I'm getting very curious. How does it look when formatted by tilde s? After watching numerous records being formatted in log printouts and so on, I'm curious, how would the map look? Tilde s.
Well,
Or tilde p, of course. S is the string.
I don't remember if we have any special new formatter for maps. I don't think so. We can try. Oh, that's the wrong one. I knew I had 2 Erlangs here. That's the wrong one. Again, this is the right one, I think. Yes.
It would suffice if you tell me that I see the key names.
What?
If I see the key names along with the values, then I'm satisfied, I think.
Yes, I think you do. Tilde P, you said. Two.
Marvelous.
Okay. I mean that's the same as if you just create the map in the shell default printout, I think. Like that. Oh.
Okay.
But you cannot choose the difference between maps and records in this aspect is that in records you can declare the field names and you get them out in the same order. But in records, of course, you don't get the key names if you don't know them by yourself. So here it will be an
Okay, we've got one
order
over there, one
decided.
down here.
Do you have a quick way to define a map with a certain amount of keys and you get the default value for a key, for example, undefined? If you want to have a map to replace a record with a map, then you maybe want to create it with 5 keys in the beginning, and then you can use the syntax to update the keys.
No, you can.
Because here you give them the value a equals 1. Could you just say map AB, and then you have a equals undefined, for example?
No default values. You have to give the default. You can use the merge functions then. You create one with some kind of default values and then you merge them together.
Yep.
That's the way it goes right now anyway.
Okay, and another question. So could you have a function as a key?
Yes, I think you can have any term as a key.
I think we had One more question over here.
Hey, I'm just curious about the pattern matching on the empty map there. Like, I mean, it seems inconsistent. Like, if you have an empty list in a function, it only matches an empty list. If you want to know, you know, whether it matches any list, you use isList. It seems like this is the exact opposite of that, the way legacy Erlang behaves.
I think you are right in that it's different from the empty list, but it's similar and consistent with the matching of records.
Okay, fair enough.
But there you match, of course you have the record name in the syntax then, but you don't care about how many keys.
Okay.
I can also give one comment to that. An empty list is actually different data type from a list, right? They're actually, internally, they are actually different data types. The fact that you have to end with a list just a hack, right? Which became long before Kenneth. That's not Kenneth's fault. That's our fault. Okay, any more questions? No, right. Well, thank you, Kenneth.
Thank you.